So today we're going to be translating. We are going to be translating from English into mathematical representation, okay? From English into symbols. And we just wrote down all of those key words there that are going to be helpful for you. Now, we all have different ability to read. Some of you consider yourselves good readers. Some of you consider yourselves not so good of a reader, possibly, and that's okay. The bottom line is, what we will be doing is we will be, here. There you go. What we will be doing is we are going to be identifying the key terms. So all those words that you see up there at the top that you wrote down, we are going to identify those. What I'm going to do is I'm going to highlight it, but what you can do is you can simply underline it, underline them. For each example below, define a variable, write an equation, and find the solution. Those are 3 points that you're going to have for each of the 10 questions on your homework tonight. Okay? You only have 10 questions on your homework. These examples, we have 6 of them. These examples, we have 6 of them. So I'm going to get my highlighter out. Find a number such that 3 times the number increased by 7 is 52. And as you guys can see on your desk right now, you can still see those words. But as far as this video goes, you can't see it, but that's fine. So if I'm going to highlight these ones, the first thing I'm going to do is I'm going to find such a number that 3 times the number increased by 7 is 52. So I want you to underline those 3. Or if you have a highlighter, highlight those 3. Underline those words, those key words, to be able to translate words into mathematical symbols. Now it says define the variable. Now we won't get into more advanced defining of a variable until another couple examples from now. But I want to be able to do both the easy and the hard version of it. Yes? How about you give me a variable? What are we going to use? X. So we would say let X be a number. Let X be a number. See, there's that number. Let X be a number. Yes, sir? If this is an example for your homework, what do you suppose? Yeah, this is how I want it. Let X be a number. Now I have to write an equation from this. So I now have to translate those words into symbols. So first off, I'm going to just go in order, such that 3 times a number, 3 times x, is increased by, which above it says that's addition, 7. And that is, equal sign, 52. That is 52. My goodness, it's warm. Not really. It might just be fake. So I'm going to come over here to the workspace. Now this is what we did yesterday. So I have 3x plus 7 equals 52. So now I have to do this 2-step equations. And remember, when you do 2-step equations, when you're solving equations, it's PEMDAS backwards. Oops. Oh, wow. So it's a SAD MEP. It's a SAD MEP. S-A-D-M-E-P. And it looks like this. So it's the SAD MEP. It's my desktop background now. Question, Jack? Shh. Shh. Because the order of operations is used to solve an expression, but this is solving an equation, and we have to go backwards to find out what that x is, because this is already said and done, but we don't know what x is, so we have to work backwards, and the backwards order of operations is SAD MEP. So I go through, do I have any subtraction? No. Do I have any addition? Yes. So I have to do the inverse of that addition. I have minus 7, 52 minus 7, 45. That 7 is now gone, so I have 3x equals 45. Yes, ma'am? I do not. What is it? Bod, boss? How? Oh. I like it. They do brackets in there as well. Yep. Interesting. Interesting. Now we have to do the inverse of whatever's happened to the x. We have multiplied by 3, so we have to divide by 3. And I'm going to be going through this faster than I did with my other classes because I'm capturing this period. And x equals 15. And remember, you can still always go back and substitute that in for x to make sure you didn't make any mistakes. Because if we substituted 15 in for this x right here, we should get 52 equals 52. Any questions on the first one? No? Good. 5 times a number increased by 11 is 19. 5 times a number decreased by 11 is 19. Jack? Okay. Let R be a number. It is now because we just defined it. Yep. Yep. That's right. Next one. Write an equation. I'm going to translate the parts that I highlighted in correspondence to what we had at the top of this page. So 5 times a number. 5 times a number, 5r, decreased by 11 is 19. So all I'm doing is just reading. 5 times a number, decreased by 11 is 19. 5 times a number, decreased by 11 is 19. So now I'm going to solve. And I'm going to write this down again because I can't see it right in front of me. So I have, right away, I have subtraction. So I need to do the inverse of that, which is, everyone? Addition. That just leaves 5r equals 30. Yep, and the inverse of 5r, since we want to get the variable by itself, stop tapping, stop talking. If we want to find the inverse of multiplying, we have to divide by what's connected to the variable. So I have to divide both sides by 5. I'm going to come out to get 6r equals 6. I want you to try this one. I'm going to give you a couple minutes to start this one. I don't want you to, yeah. I'm going to give you a couple minutes to do this one. I'm going to circle around. There's what you missed. repeat that? I can't hear you. Speak up. Yep, you pick any letter you want. Hopefully you've underlined the key words, considering I told you that's what you need to do. You can have any variable you want. I chose y. Did anybody do anything different for their equation? Did you do something different? Oh. What's your question? No, explain it. Put it in words. Can you 13 and 4? 4 first, and then plus 13y? Yeah, that matters. That's not what it is. There are two things you could have here. You could have 4y plus 13 equals 91, or negative 91, or you could have 13 plus 4y. Those are both the same thing through the commutative property of addition. Those are both the same thing through the commutative property of addition. So now I'm going to solve it. And I have addition there and sad met. That means I have to do the addition first. For y, I'm getting more to the negative. I have negative 91. When I subtract 13, I'm becoming more negative. So that number is going to be a higher negative number. Like that. Then I have divided by 4. Negative 26 is the correct answer. And if you did that in your head, that could have been done because you think about how there's a quarter is 25. Negative 9 is the quotient of a number and negative 3. I had students come up with this earlier. Of a number and 3. Not that one. Back up. Increased by 11. I had a student come up here each class, and both of them I kind of challenged them to see if they could get this. I'm going to read this as it goes and write it down accordingly. First off, define the variable. I don't like eyes, especially because they look like possible ugly ones. W? Ooh, Z, yeah. Now make sure that you have that line through that Z so it's not looking like a 2. You should have that line there so it doesn't look like a 2. So let Z be a number. It says here, Negative 9. Negative 9 is the quotient of a number and 3. The quotient is the answer to a division problem. Okay, what do you think it is?
I think it's negative 9 equals negative 3z plus 11.
Negative 3z would be multiplication. Mandy?
Negative 9 equals negative 30, negative 3, no, okay, so it's z over negative 3.
There you go.
Plus 11.
Good. Yep, and that is correct. Good job. So I have a two-step equation now. I look at my SADMEP, and I'm like, oh, SADMEP, what should I do first? And my SADMEP looks at me and goes, you should use the what? Addition, subtraction. Now this one here, I know a lot of people with which they could have struggled. Because you are stuck in the 5th grade version of having a division sign rather than looking at a fraction as being actually division. Okay? Rather than a fraction actually being division. So in order to undo what's happening to my variable here, what do I have to do? Avery. Good. You have to multiply by 3. Oops, I missed a negative. That should be negative. I have to multiply both sides by a negative 3. So now my solution is going to be z equals a negative times a negative. Is it negative or positive? Positive. Beautiful. Positive. So I have a positive 60. The lights are often off like this. It usually is. It's just cloudy out, so it seems like it's darker. In one season, Kim ran 18 races. This was 4 fewer races than twice the number of races Steve ran. How many races did Steve run? Now, here's the things that you should be recognizing about this. Well, actually, no. What can someone tell me? What do they recognize about the difference of this? Raise your hand. How does this differ from the ones before it that we've been doing? Yeah, Megan? Beautiful. It's a story problem. Now, these are the ones where defining the variable is very important. Okay? These are the ones where defining the variable is very important. If I had to define my variable, who wants to take a stab at it? What would I define it as? And this time I'm not just asking for what letter you want to use. Owen? As I just said, I'm not looking for what letter you want to use. Loyette?
How many races Steve ran?
Good. Let R be races Steve ran. Let R be races Steve ran.
R.
Mm-hmm. In one season, Kim ran 18 races. This was 4 fewer races than twice the number of races Steve ran. Now, what are they talking about this? This was. Well, what was? 18, exactly. This, they're referring to the races. So we have 18 is equal to 4 fewer. Now I want to show you a common error, so don't write what I write right now. 4 fewer races than twice the number of races Steve did. Good. Exactly. I did that wrong. I was just seeing a number and just being like, oh, I got to write it down. Right? You got to think. It's actually like this because it's 4 fewer. And I'll elaborate a little bit on that. If I have, or do you agree that 2 is 4 fewer than 6? 2 is 4 fewer than 6. 2.
Attention in the building, please pardon the interruption. Tonight, there will be no tutoring in the media center. Tutoring is canceled in the media center for today. Please allow students to call home if necessary. Again, there will be no tutoring in the media center after school today. Thank you.
So like this, on this one here, we have 2 is 4 fewer than 6. But if you were to do it the wrong way, 2 is 4 fewer than 6. Is that true? Yes. No, I told you not to write that stuff. All right. Back to the action. So 18 equals 2r minus 4. So now we're going to solve for it. 18 equals 2r minus 4. Yeah. I have sad MIP. I have subtraction right here, so I have to do the inverse of subtraction, which is addition. I'm going to add to both sides. That just leaves me with 2r equals 22, my favorite number. Then I stop talking. Now I have 22 equals 2r. I have to do the inverse of what's happening to the variable like we've been doing since September. And by the way, if you have gum, spit it out now. I found 3 pieces of gum stuck to the bottom of desks just today. This is your chance. I'm cracking down on gum. Yep. Cracking down on gum. And that gum that's underneath your desk, that's the reason you don't get the privilege to chew gum. I did not ask you to have a conversation about it. Shut your mouth. Let's go. I'm telling you what's up. No gum whatsoever. Don't forget that you have gum in your mouth when you come into this class if you can get away with it in other classes. So we have 22 divided by 2, which is 11. So we have 11 equals r. I could put r equals 11 as well. It's the same thing. Now this one is tricky, tricky, tricky. There's one just like it on your homework too. Yeah. That's what it's like every day. Same thing. Whatever. Okay. The length of a rectangle is 4 times its width. Find its dimension, or the perimeter is 90. Find its dimensions. Use the formula, perimeter equals length times 2 plus width times 2. So that's 6th grade perimeter stuff with 7th grade pre-algebra stuff. So I'm going to highlight this information. The length of a rectangle is 4 times its width. So let x be the dimensions. So when I'm done with it, it's going to be x equals length times width. So my equation for this is my x is length times width. No. Sorry. Yeah. The dimensions are blah, blah. Yeah, like a 2 by 4. Those are the dimensions. Garrett, sit someplace that you're not going to be distracted by people around you. Okay, thank you. That's acceptable. I apologize. So we were told that the length of a rectangle is 4 times its width. Its perimeter is 90. It gives this to us. So I'm going to go ahead and do 2L plus 2W. But here's the thing. We're going to be erasing one of those. What do we know about the length? What do you know about it? It's 4 times the width. So if we had the length equals 4 times the width, I just defined L, didn't I? I said exactly what the value of L is. Look what we have right here. You know, move up. I'm tired of seeing you squint at me. Are you done?
Yeah.
Sit. Yeah, just move your stuff to Joey's desk. Because you're wearing your glasses, so you can still see. We have the value of L, don't we? We have the value of L, and L is right here. So let's substitute that in there. 4W for right now. So I'm going to write 90 equals 2 times 4W plus 2W. So let's solve for W. Combining like terms. I love combining like terms. Combining like terms is just so much fun. Yeah. Fake fun, but fun. Yeah, we can act like it's fun. Fake it till you make it, right? Now I have the inverse of 10W is 10W divided by 10. Now I have 9 equals W. So I just found what W is. So if my X is going to be length times width, or that's going to be my dimensions, so I now have, I'll do this. Width is 9. Length is something. Abby? Can you repeat that? 10. Like this? 1. If I remember correct. So we have 9 equals W. Is there a way that we can find out what L is now, Camden?
9 times 4.
Exactly. Length equals 9 times 4. So we're taking this. And 4 times 9 is? 36. Yes. That's an L. That's an A. Ugh. That does not look like an A. Yes. You'll find out in a couple minutes. No. I'll answer that question. No. Yes, Joe. Right, because I'm using the backside. Did you already copy all that down? Okay. Now, these next 3 questions are review to get you ready. What you guys talking about? Yeah, this is... gotcha. Worry about that later when I'm not in the middle of the lesson, yeah? Thanks, guys. For these next 3, this is a review for some of the park stuff, and also so you guys can know what's going on, and also so you don't forget that the order of operations, regular, still fits. It's not always going to be a sad map, okay? It's going to be a sad map. There's also still, please excuse my dear Aunt Shaniqua, okay? So let's evaluate, and that's the correct mathematical term for substituting, like plugging it in and chugging away. So we have, these are defined here. I've had to answer that question for 3 kids already today. It's right there. I just drew lines to it. It tells you what the values of each of them are. You don't have to find it. They're telling you. It's the exact opposite of what we were doing the last couple of days. So I have 2 times 3 minus 4 equals something. I have to do the order of operation, which is PEMDAS. It's 2 times 3 first. Then I do the subtraction, and that answer is 2. I want you to do number 2 and number 3 on your own, and then when I see what you've got, we will be getting the homework. And that's the conclusion of this video. You look beautiful today, person watching this.
Thank you.